Hello and welcome again to Java. This is tutorial number 3. Today we're going to be going over getting user input over a command line, like hey, please enter your name and then they enter it, as well as the random number generator class. So here we go. So what are these classes a part of, this random number generator and this scanner class? Well, they're part of java.util. So we got to import that. Import java.util.wildcard. The asterisk is the wildcard symbol. That means everything in there. Imagine like a folder hierarchy where Java is a folder, then inside you have util, which is a folder. This wildcard says everything in the util folder. Grab all that, bring that in. The only thing to note here is that java.wildcard would not work because it only imports, when you go java.util.wildcard, it looks in util and it says, alright, where are .class files? And it pulls all the .class files, or basically all the classes. Pulls all the classes. However, it's not looking for other packages. It's not recursive. If you import java.asterisk, it doesn't import anything in util because util is a package, not a class. So you do have to import specifically that all the classes in that folder. You can't import java.asterisk or import asterisk, everything. I want everything. You can't do that, so you do have to import java.util.asterisk to get these things. Or you can import java.util.scanner and import java.util.random separately. You can also do it that way if you want to be more selective with what you import. However, you're not going to notice any kind of dramatic performance decrease or drop from importing the entire folder of anything you need. That's the commonly accepted way, especially when you're working with 2 or more items in that package. Just import the whole thing. I've seen a lot of people import between tutorials and other people's code and whatnot. I've seen a lot of people import, they have 20 imports and 10 of them are in the same package. And, well, actually, just if you put these all in one, oh, but that's extra resources. No, you imported all of the classes but one, So anyway, import java.util.asterisk or wildcard. That will import random scanner and a bunch of other things that we're not going to talk about right now. Don't need them for this tutorial. Now, today we're going to be introducing how to create objects of classes. How to create an object of a class. An object of a class is basically an instance of that class. And it's a little bit hard to wrap your mind around for just a second if you're new to object-oriented programming, but it makes sense quite fast once you get the hang of it. So, let me give you the syntax and I'll explain it. This is to make a scanner object. Scanner in equals new scanner, system.in. Now, what does this do? Well, from what you know, this equality sign says whatever is over here equals this, basically. In is our object name. It is a pointer. Scanner is the type. It's like saying int, or double, or long, or float, or byte, or char, or boolean, or string, or whatever. I may have repeated them, but I may have repeated when I said that, when I rattled off that list, but whatever. Scanner, so the object in is of type scanner. It equals a new scanner of type system.in. Now, this is the new part. System.in is, and they explain it pretty well, the system class, like we use system.out.println, also has system.in. In is an object, it automatically exists, and it's basically standard input. Whatever the standard input is linked to, whatever the standard output is linked to is system.out, standard input, system.in, that's going to be your console input. That's going to be the input that appears here. It's going to say, hey, welcome to the program, or whatever, please enter your name, and then the input, you enter your name, that's where system.in is going to be working on that default input channel. So, it creates a new scanner of that type. New scanner, it instantiates an object, and it passes its constructor, which we will talk about later as well, the object system.in. It's kind of a magic object, you never have to instantiate system.in. So, what do we have here? What does this do? This creates a scanner object, and what can we do? A scanner object now has a bunch of awesome classes to get user input, which I'll show you in just a second. So, let's do, this should be all familiar right now, system.out.println, welcome, please, plessy. Please enter your name. Alright, great. So far so good. Now, this is the new part, user input. Let's first create a string object. String username equals, and what do we set it equals to? How do we get that user input from that scanner object? Well, in.next line. Next line, and also with another nice thing with Eclipse is this, watch. In dot. It lists you all the methods you can possibly call. So you can look through and say, alright, it was next something. Was it next? Oh, that's right. It was next int with a radix or whatever. And that's pretty cool. I never knew that I had that. But anyway, in dot next line. Next line is saying the next line of input between the last return character or the beginning and the next return character, return key, basically enter character, whatever you want to call it. Whatever is between those two is what it's going to give you. So it sets that string equal to it. Then we can do system.out.println welcome plus username plus exclamation mark. So let's explain how we did this. Well, we know system.out.println accepts a string and then prints out that string to the console, correct? Now, what if we want to put multiple things? We want to, dynamically say welcome and then input some text that's the same every time, that's different every time we run it, and then something that's the same every time we run it, like the exclamation mark and the welcome part. Well, we do that with concatenation. When it's enclosed in string literals, remember, it's always the same. It doesn't change. It's immutable. Now, that applies to this welcome space and this exclamation mark. Username, however, is a pointer. When working with strings, the plus sign is concatenation. It basically takes welcome and then gets whatever the value of username is and then smashes them together and then smashes on the exclamation mark and makes a new string out of that and passes it to the println class. So, in here you have basically one expression, one thing that you're passing to it, which is a string, and you're doing the construction, the making of the string. Construction is a bad word there. The making of the string inside, and then you are sending that result, that welcome plus username plus exclamation mark, that concatenated string, to the println method in the out object of the system package. So, let's run this real quick. Welcome, please enter your name. Best Mac Tutorials. Enter. Welcome to the Best Mac Tutorials, and then that's it. That's all the program does. Now, what if we wanted a password? We'll get into passwords with file.io, but just for now, let's say we have the password hard-coded in. So, int passcode equals 7001. Just whatever. Then let's take this and put this down here. And let's say system.out.println. Please enter the passcode of the user plus username plus, and then let's put a period. Alright, so what does this do? Well, it shouldn't give me a red line, it just sometimes does that, it's a little bug. In.nextLine gets the user input and assigns it to, assigns whatever that value is that's entered, that string that's entered, to the pointer username in memory. So, username is then equal to the name that they input when it said welcome, please enter your name. They entered a name, put it in. Then it says please enter the passcode of the user, and then it says the username and then it has a period. Again, concatenation concatenates this with this and then with this, creates that string, then sends that string to println. Don't worry about the sending process, how that works. We will get to that in a little bit, not in this episode. But when we start working with creating our own objects and doing our own methods, that is when we will jump right into explaining how this passing works. For now, just understand that this has to receive some kind of string, and you are giving it some kind of string. Something else to mention real quick, don't want to take too much time on this, but this plus sign is not addition, it's concatenation when working with strings. If you have 3 plus 4 without any quotes, it'll give you 7. If you have 3 in quotes plus 4 in quotes, like this, 3 plus 4, and then obviously that's going to give me an error, but if you had 3 plus 4 like that, it'll give you 34, whereas 3 plus 4 is going to give you 7. So it automatically detects. If it's something it can add, like an integer, like a boolean, or not a boolean, sorry, like an integer, like a double, long, short, byte, whatever, it adds them, else it just mushes them together. What if you add, you know, quotes 3 plus, and then no quotes 4? Well, it still sees there's a string in there, so it's doing concatenation. If you add 4 plus 5, here, let me type this out. 4 plus 5 plus 3, it goes left to right, so it goes 4 plus 5, alright, that's 9. Oh, wait, string, 9, 3. So the result of this would be 9, 3. If that doesn't make sense, if you just always want to be on the safe side, always make sure you use quotes in the right place, or else you will get really screwed over, and you won't be happy. So be careful, it's not going to parse that string into an integer unless you tell it to, which we'll also get into at some point later on. So please enter the passcode of the user username. Now, why did I do this? Well, it's twofold. One, I want to show you how to use the comparator operator, nice catchy name, which basically decides if two things are equal. Two primitive data types are equal, might I add. With objects, it's a little bit different. So, also, it shows you how to, instead of in.nextLine, because that's a string, how to test, how to input an integer. So, please enter the passcode of the user, then string passcode from user equals, what do we want it to equal? In.nextInt. Next line is for strings, next int is for integers. And cannot convert from int to string. Right, we need to set this as an integer. Int passcode from user equals in.nextInt. Passcode equals 7001. So then we'd say, this is also going to show you if statements. If passcode from user is equal to passcode, then, and I will explain this in just a second, this looks a little bit complicated, if else system.out.println access denied. Alright, so what does this do? How does this work? Why is it here? Well, an if statement says if this is true, then execute whatever is between these. So it evaluates this. Else says if this is not, if this is not true, then do this. So if this is true, so true, do this. If this is false, do this. I hope that makes sense. If you have any questions, again, always remember you can always post a question in the comments or send me a message on YouTube and I'll try my best to answer you. And this is the first episode that I will actually put the source code up on the website, or not on the website, on Mediafire, and I'll put a link in the description for anyone who wants to download it and look at it, try it out, whatever. The source code will be available. So, anyway, if passcode from user is equal to passcode, notice the two equal signs, then do this, otherwise do this. So, how does this work? Why are there two equals? Well, one equal is for assignment. It's the assignment operator. It says, take what's on the right side and assign it to the left. Not to say you'll never see single equal signs in an if statement. A lot of times you do assignment and then you check something. So you say like, you know, for int I equals 0, that's one equal sign, and then if I is equal to for less than or equal, you'll have multiple equal signs, or a less than and then an equal to sign, whatever. You will see single equal signs in if statements at some points, and as well every for loop is going to have it, if it's not a complex iteration for loop, instead the normal notation for loop. But you will see this occasionally in an if statement, just one, like that, where it's doing assignment, but as you see this gives us a red line. We have to do two for comparing to see if they're equal. Passcode from user equal passcode. This is a Java built-in function that'll return either true or false, a Boolean value. If true, this, if false, this. Basically is what that is. So, if it's true, then we want to say welcome. They entered the right passcode. If it's false, we want to tell them access denied. So let's play it. Let's start it. Please enter your name. The Best Mac Tutorials. Please enter the passcode. What's the passcode? 7001. Enter. Welcome, The Best Mac Tutorials. See how easy that was? Real simple, straightforward user input. It's very easy for the user. Now, what else can we do with user input? Well, let me show you. We can do, basically, and there are some more complicated things, there's some things with array lists and whatnot, but basically, the other very useful feature of the scanner class that we're going to be using in the near future is up here, has next. So that's saying this returns a Boolean value, they all return Boolean values, and you say if it has another integer then tell me it's true, otherwise say false. So say you're importing text and you want to know when you reach the last line. If in.hasNextLine, a little bit down here, has next line. So if that returns false, then you know you're at the end of the line and you can move on. Otherwise, you know to keep going. You know to grab that value. So these are very useful. Has next and next. Basically, once you add a has, it converts from returning the value that's there to returning whether it's there. Very useful. If that doesn't make too much sense right now, don't worry, we will go over it later. Now you'll notice this if statement doesn't have a semicolon at the end, and if we put one, well, it wouldn't exactly work. Because else would be like, huh? So what does this semicolon missing mean? Well, it means that this is a complex statement. This isn't the end of the statement, however, statements inside end with semicolons. So if I had 3 lines, I'd put a semicolon at the end of each one. If I had 3 system.out.println, if I did this, like that, each one would have a semicolon at the end of it. Likewise, same thing, although it looks better, there would be a semicolon at the end of each line. Complex, however, if something that's a complex statement, it involves a block of code, you don't have to put a semicolon, and in fact it won't work if you do. A little shorthand, if you only have 1 line of code, you can do that. This will work the exact same. If this, else this, instead of all the brackets, however, if you put 2 lines of code here, it suddenly won't work. So you have to just keep that in mind. But with 1 line of code, you can remove those brackets. And as you can see, it still works just as intended. So 1 line is okay, but if you have more than 1 line, then you're going to need to use the brackets to make it a block of code. Now, what about the random class? I'm going to put those back in for readability. I personally like having them. It helps me understand the program's flow a little bit better. But if you want to kind of save space, make it more concise and hard to read, go ahead and do that. Now, what is the random number generation in Java? Is it good? Yes, it is. It is very good. And what does it rely on? Well, think for a second and imagine. This is how a computer works on a very, very low level. It just crunches numbers. All it does is basically take input, do something to it, give output. Take input, do something to it, give output. Is there any way for any completely random number to be generated? Not used by, but generated by a computer of this type? No. However, you can hook your computer up to something like a Geiger counter in order to get actual random numbers generated from radioactive decay or radio signals in space from any number of cosmic events. You can do that for sure, but if you just want your computer to generate a random number without having to go over the internet and pull someplace that has a Geiger counter hooked up or attach a Geiger counter to your computer and have radioactive materials decaying near it, then there's another solution, and that's pseudo-random. Pseudo-random takes some kind of seed and does something to it to pull up random numbers, seemingly random numbers. And it basically, in Java, takes the system's current time in milliseconds as that seed. What is a seed? Well, if you've ever played Minecraft, you know a seed, while the world generated from a seed in Minecraft looks very random, you know, it doesn't like print out the words of the seed or anything. However, every time you generate a new world with that seed, it'll look the exact same, assuming the same generation engine, same version of Minecraft. So, why is this? Well, it uses a seed, and from there, it makes random choices. The random algorithm performs mathematical operations on this random number to get, or on this, the time, the seed, or whatever. You can use your own seed, but by default it's the system's current time in milliseconds, like I said. But it does a bunch of mathematical operations on that seed in order to come up with what seems like a random number. The distribution is very good. If you ran 1,000 trials of like random numbers between, you know, say 1 and 10, it would be very evenly distributed. There would be, of course, you know, 1 or 2 extra in one and 1 or 2 extra in another, but it's really close, and each time you run it, it'd be different ones that have extra. So it is a well-distributed system. It works very well, and for our intents and purposes, those numbers are essentially random. So moving on, we'll create a random object, much like we created our scanner object, except we don't have to pass it anything. Right, tandem, random equals new random. If we wanted a seed, we'd put that in here. If we wanted to. But, however, right now we don't. a random number object is created. It's called random. It's of type random, and it's set equal to a new random object created with no parameters passed to the constructor. Pretty straightforward, pretty simple. Considering we went over in depth what initializing a scanner object looks like and how that works. So random numbers. Well, let's say system.out.println. Here are your random numbers, and we only want them to be able to do this if access was granted to the machine, or else it's going to say access denied. You're not going to get your random numbers. So here are your random numbers, and then it's going to do, we're going to do system.out.println random.nextInt 100, and then plus, let's put a comma, random.nextInt 100, and let's actually break each time we do this, plus, and so we'll do this, watch, we'll go here and put an enter, plus, comma, space, plus, let's put that plus here, random.nextInt 100. So, what does this do? Well, first we broke it apart for easier readability and working with it. Breaking it apart, again, at white spaces doesn't matter. However, it probably is more readable, aside from the font size being too big so it bleeds off the edge, to have it like that and have this line up over there. However, this is better for readability with a larger font size or longer lines of code. So, it'll print out 3 random numbers for them. Now, are they yours? No, but who cares? They are random numbers, so let's run this. Welcome to the best Mac tutorials. Passcode 7001. Here are your random numbers, 98, 47, 53. 98, 47, 53. Remember those. Let's run it again. Doing everything the same way. Please enter the passcode 7001. Obviously, these are not the same numbers we had before. So, and is it any coincidence that 2 of them are in the 90s? Yeah, it's a coincidence. So, those are random numbers. Now, what if we wanted to make them so they're the same for every user? Well, we create our random with our username. So, the username. However, the random class needs the input of an integer. It cannot work with a string. How do you make an integer out of a string? Well, there's one convenient class called hashcode. That's a tongue twister. Say that 3 times fast, or 20. We do this. Username.hashcode. Hashcode returns a hashcode for the string. This is how it's calculated if you're at all interested. Basically, it's a unique identifier. If you hash a bunch of different usernames, more than likely they're not all going to be the same. You can't look at a hash and really reverse it, that I know of, back into a string, but however, you can hash a string 2 times and it'll equal the same thing both times. This is how databases, a lot of databases with password authentication work. And this is kind of a tangent here, but they say, alright, well, we have this convenient, nice, easy to use SHA-512 hash. All we do is call SHA-512, put in our text, and it gives us a hash. Obviously, there's a little bit more to it, but that's simplified. So, we don't want to store user passwords because we don't want someone to hack our system and have all the passwords. So we're going to put the hash instead. And then whenever a user submits their password, instead of checking to see if the password's equal, we hash the password on their end. Their password is never sent over the internet, and their password is never stored on our end. Maybe on their end if they have certain things like remember my password checked or whatever. But generally, it's not stored nor transferred. Instead, it is hashed and then transferred. You can't reverse these hashes. You have to just brute force your way to getting them because they use multiplication, which is non-reversible, and other things, other more advanced algorithms that I haven't bothered to look into. But if you have 4 and 5 and you multiply them together and you get 20, yeah, that's right, then you can say, alright, well, 4 times 5 equals 20. And then next time they send you 4 times 5, you can make sure it still equals 20. However, you can't get 20 and say, oh, they entered 4 times 5. It could be 2 times 10. It could be 1 times 20. It could be 0.5 times 40 or 0.25 times 80. you get the point. 0.125 times 160. It could be any number of those, and you don't know which one it is. And there are almost an infinite amount of possibilities. There are an infinite, actually, amount of possibilities for how many things could multiply together to 20. We like to say, oh, well, 1 and 20, 2 and 10, 4 and 5, and that's it. No, 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 no. Start working with decimals and you'll find out otherwise. So, hash codes are basically non-reversible. Something like SHA 512. It's going to be a lot more secure than our java.hash code, but this is good for our use. So every time we create a random object, it'll give us the same results. So watch this. The best Mac tutorials. Passcode 7001. 83, 38, 16. Remember those. Run it again. The best Mac tutorials. The exact same spelling, 7001. Enter. 83, 38, 16. Was that a coincidence? I'll run it one more time to prove that it wasn't. The best Mac tutorials. 7001. 83, 38, 16. There's no way that that could be just a coincidence. It is based on the seed. However, it's based on the username, so if we use a different username, won't that give us different numbers? It will. Say the worst Mac tutorials. Enter the passcode, 701, still it's hard-coded in. 16, 71, 46, completely different. So, we made random numbers based off of something that's not random, so they become predictable. Why would you ever want to make random numbers predictable? Well, there's a couple of good reasons. Something like Minecraft may use it so you can generate the same world in two different places. Somewhere like another video game could use it so it generates the same levels each time. So it doesn't have to program in all the levels, but everyone plays the same order so it's completely fair. It generates the rooms randomly, but randomly in the same order as everyone else, with using the same seed, so that everyone plays the same levels, and it can be 100,000 levels long, and they never have to design any one of the levels. It just automatically does it for them, but it's uniform across every single game, which is a really cool thing. Another use, for testing. If you want to test to make sure something's working, you may want output that you can expect, that you can predict, to make sure it's giving you what you think you should be getting. So there's a number of reasons to use a seed for a random number generator. It's not just useless, there are plenty of good reasons. It's also good for like encryption. Because if you generate a random number based on what's entered, well, once you do more multiplication, everything, convert all the symbols over to numbers, there's no way you can, just take that apart and reverse it really easy. It'd take a lot of work to be able to reverse, if at all, if not just brute forcing. But not just that, it's predictable what random numbers you're going to generate based on the username that's entered. However, looking at it later, that string has an entirely different hash code, so different numbers would be generated, so you can't reverse it by finding what random numbers were generated unless you know the original username, which you don't know. You're trying to hash backwards towards it, or the original password or whatever. So that's how the random object works. That's how the random class works. Something else to add that's interesting might be the random.nextDouble. Random.nextDouble generates a random number between 0 and 1 with decimal points. So 0.8468289, that's one of the numbers it would return. It's very useful for then multiplying out. Like if you want something with a certain distribution, say opacity, and you want a random opacity or something. Or for whatever reason you need a random decimal, like say a modifier for the amount of XP earned. Well, you could always weight it too. Now, something interesting to note here is random.nextInt 100. 100 is passed to the constructor, and it says, or not to the constructor, to the method nextInt, sorry. And it says, hey, I want a number in between 0 and 99. Why? Because it says I want a 100 number range, and it always starts at 0. Now, what if you want a number that is between, say, 10 and 15? Well, let's try this. Between 10 and 15, random.nextInt 100. Let's do a new one out here. System.println, access denied. Println. Here's an odd random number for you. Just random, why not? And then system.out.println. And what do we want in here? We don't want quotes, that's for sure. Random.nextInt 5. Why? Well, what's the difference between 10 and 15? 15 minus 10 equals 5. Then add 10. Why? Because the bottom minimum amount you want is 10. Now think about this. Random.next out O-U-T. And random.next, oh right, we need to put this here and remove this. And we're all good. Actually, we could leave that in. So, what does this do? Well, imagine all the random numbers between 0 and 4. And let me write them out here real quick. 0, 1, 2, 3, and 4. 0 and 5, or between 0 and 4 are 0, 1, 2, 3, and 4, because it is inclusive. Now if you add 10 to each one, 0 becomes 10, 1 becomes 11, 2 becomes 12, 3 becomes 13, 4 becomes 14. However, you don't have that 15. What if you wanted to add that 15? Well, you just change this 5 to a 6. So now you have 0, 1, 2, 3, 4, 5, 5 to 15, so now you have 10 through 15. So adding the 10 just shifts all of them up by that amount. So if you want between 100 and 150, you do random.nextInt 51 plus 100, that minimum value 100, to account for that 0. Then everything else will bump up accordingly. So that is how you use the random number generator class and how you use user input. Thank you for joining me. This source code will be linked to in the description on a MediaFire download of this video. Video description of this video, MediaFire download link to the source code. Thank you for joining me, and I will see you next time.